Okay, so the first section is on index laws. Actually, in grade 9, because last year you used the textbook, and we really didn't do any of this last year, and thirds as well. So you're a little bit behind what the previous year is, who didn't use the textbook, because this section I actually taught a lot of this in grade 9, but it wasn't actually in your textbook, was it? So we'll go through the basic rules here quickly. So index laws. Now, when you're multiplying numbers that are written as powers, we add the power. So for example, if you've got 4, 7 times 4, 11, you would get 4, 18. So that would be 4, 7 plus 11. Okay, you get 4, 18. So this is your addition rule here. And we do that when we multiply the two numbers here. When we're dividing them, we will subtract the power. So in this case, Z6 divided by Z4, we would subtract these powers. So Z6 minus 4, Z2. I know you know a lot of this already, but further down, there's some new stuff. Now, this is very useful as well, which you did a lot of this in grade 9, this kind of rule. So when you have two numbers with the same power, we would multiply the numbers and then just write the power. So for example, 2 power 4 times 4 power 4 will be 8 power 4. Okay, so you just basically write your numbers, multiply them, and then you write the power down here. Okay, and when we're doing similarly, when you divide the number, we can put these two numbers into a bracket here and make them to that power as well. I won't prove all of these because that would take like 2 periods. So just take my word for it for the time being. I say, for example, 4 on 7, 12 on 7 is 4 on 12 to power 7. And the 4 on 12 can simplify to 1 on 3 power 7. Okay, so just leave the power alone here and join the numbers together. So that's when you have same powers. So I should write that there. So same power or index, same power. And the previous one, we had the previous two, we had the same base because that number's the base. This is the base number. So these are same base. And this one is same base. Okay, so we need something the same. So for example, if you had 3, 4 times 2, 3, you can't use any rule here because you see the bases are different and the powers are different. So there's no rule you can use to simplify that using those rules there. Now, anything to power 0 is 1. So you can check that on your calculator. 3, for example, let's think about why that's true. If you've got 3, 4 divided by 3, 4, you're going to get 1, aren't you? Okay, because that would just simply cancel out. 3, 4 on 3, 4 is 1, isn't it? But if you had 3, 4 divided by 3, 4, when we divide, we subtract the power, don't we? Back to the previous rule. So that would be 3, 4 minus 4, which is 3 power 0. So 1 is equal to 3 power 0 in that case. So anything to power 0 is 1, and your calculator will do that anyway. Now for your negative powers, which you probably didn't see too much of last year. So if you want to get your calculator and check 3 minus 1, that would be written as the same as 3 on power 1. So what you do, you just basically move your number down and change the power sign. Okay, so for an example, How did we get a negative? So 3, 4. Divide 3, 5, like that. So that's 3, 4, 3 power 4 on 3 power 5. In this case, we would subtract the power, wouldn't we? 3 power minus 1, like that. What else was I going to say about that? I'll leave it. I'll come back to that anyway and do some more explanation about this later. Anyway, so that's what happens. You basically take your number, move it down, and change the sign on the power. And you can check this with your calculator too. So bring your A6 down. A6 becomes A minus 6 in the denominator. So if you've got 2 minus 4, that would be 1 on 2, 4, for example. But if it was 2, 4, you could bring that down. It would become 2 minus 4 as well. So basically the number will move down and change sign here. Okay. One thing you haven't done much of was the fractional powers. So for example, I've written here 9 to the half. 9 to the half is actually the square root of 9. Half power means square root. So let's write that there. Half power equals square root. And a third power would be cube root. Cube root, like that. A quarter power would be a quarter root. Okay. A quartic root, I guess. How do we show that? I didn't write that down in my notes. So we'll come back to it. Okay. I'll talk about these more later. So 27 as well. 27 to the third means cube root 27, which is 3. One way you can do these, which I think is a good idea. Now 9 to the half. Okay, 9 we know is 3 squared, isn't it? 3 squared is 9. So we write a half power here. And at this point, we multiply these two powers. So 2 times to the half is 1. So we get 3. So 9 to the half is 3, which is square root 9. The same with 27 to the third. 27 to the third could be written as 3 cubed. Yep, 3 cubed is 27. Then we write the power back here, 1/3. And 3 times a third is 1, which is 3. So obviously, 27 to the third means cube root 27. Like that. That's cube root, not 3. I should make it look like a power, a root. Like that, cube root 27 is 3, which is the same as 27 to the third. Okay. So another rule which is useful, when you've got a fractional power, a, m, n, so any number, m, n, we can split this to m times 1 on n, and 1 on n is square root a, okay, and or you can write it in this form here. Now, I don't actually bother to remember this formula, this information so much. What I'll do, let's move it up a bit. Now, I've showed that formula here, what's going on with this one here. But there's another way that I think you should do this in the test. So if you've got 8 to 2/3, right? The first thing that you should do is change your 8 to a base and a power. So 8 we know is 2 cubed, don't we? So 8 is 2 cubed, and this is 2/3. So that's 3 times 2/3. That 3 will cancel. You'll get 2 power 2, which is 4, which is the same as you got here. This is the way you should show me when you do the work in the book, okay? Because I think it's easier to remember that, to do this procedure, than to remember this formula, this business up here. It still works, but it just takes a bit more to remember. But if you want to do this, you've got 8 to 2/3. What I do, I take the 3, this, and I make that the root. So what I'll do, I'll bring the 3 around like this, and then I put the 8 squared here, like that. So that's the cube root of 64. The other way you can write it is cube root 8, but then you put the square on the outside. That's what's been done here. So that's another way you can do it. So this is cube root 8, which is 2. 2 squared is 4. And that's the cube root of 64, which is also 4. It's just another way to do the problems, okay? So they're the basic rules you need to know. These last two, you really didn't do much of that in grade 8, did you? So I'll run through these examples before you do any. My arm's getting numb. So in question 1, you've got a fraction with x and y. And what we do here, they've done it, this can be done this way. So you've got x2, x4. So here is a division, okay? So that means we would have 2 minus 4 for the power. And for y, y3 on y2, which is y3 minus 2, okay? Which gives you y1. And 2 minus 4 is minus 2. And we want a positive index form. They did answer that in the question. So then we put the x minus 2 down under, and I get x squared in the base. So just change the sign on the power when you move stuff. Okay, so in this one, question B, I have a different base here. I've got 8 and I've got 2, don't I? I've got 2 different bases. So you should try always to make base the same. So make bases equal if you can. Wherever you can, you make the base the same. So 8 becomes 2 cubed here, and my power 5 comes back, and I've got 211. And 3 times 5 is 15 here, and then 15 minus 11 is 4, because we're dividing, we subtract the power. Okay. Question C, same idea. What do we got? 15, I'll use red. 15y(x4), 15. Now, what they did there, you get rid of the bracket first. So you've got 3 5s of 15 and 5y here. Then the 5 and the 15 cancel to give 3 in the denominator. 5 on 15 is 1 on 3. Okay, then we've got y, and then y5. So this is y1 minus 5. Just bring the 5 up, and 1 minus 5, and x4 here. So that's 4 minus 15, because you've got a division here. So we subtract the power. So we end up with x minus 11, then y minus 4. Now I want positive power, so you bring both of those down underneath here. So you get y4 x11, like that there. Okay, 27. So when you see big numbers, can you change the power? 27 is 3 cubed, and 10 on 6 was simplified to be 5 on 3. And then when we multiply now, that 3 will cancel that one. So you get 3 power 5. You can leave it like that. You don't have to write the number out, because that's quite a big number. So just leave it as a power form. But if you had something like 2 power 4, you can write 16, because it's quite a small number. But big power numbers, just leave them as powers. So in this question, you should be looking and thinking, I've got 27 and 9. Can I make those smaller powers? So your 27 is 3 cubed. your 9 is 3 squared, okay? So these are all reduced to powers. Try to make your base a prime number, a prime base if you can. And then I bring my 1/3 down, I bring my 1/6 here, then I multiply here. So I get 3 power 1, 2 on 6 is 1 on 3. And then at this point, now I know I can add my bases. 3 power 1 plus 1/3 is 4 on 3, like that. So you just leave it like that. You could write cube root 3 power 4. 3 power 4, so let's write that again. Cube root 3 power 4. So that's the cube root of 81. You could write that as well if you want, but this is in index form. That's index form because we have a power. Call that radical form, I guess. Radical or surd form, radical. Radical means it's got a root sign in it. It could be cube root, could be square root, something like that. That's radical form there. So in the last example, you're going to work in a minute after this one. So we've got 3, 9, 4. So I tried to change the powers. 9 was 3 squared. This has all been simplified already. And then 4 cubed is here. So that's written down there. So the other ones didn't change. But I changed this middle one here. So now I have power base 3 and base 4. Okay, and then I just basically join them together. So 3, so this here became 13 on 3. You can add that with your calculator. Your 4 on 3 is still here. 4 on 3 here. And then I did my subtraction here. And then I got this for the final answer. Now you have different base and different power. So you stop here. Okay. So just look back at that. I've just made a few notes on there to show you, but okay, do you want to try these for 5 minutes? Now, when you have brackets, we don't want brackets. All right, so I'll help you with the first one a bit. So you can start working here. If you think you know what you're doing, you keep working. If you're not sure, you can listen to me for a while. So when you have a bracket, everything to this power. So that's 6 squared. And then as you have a bracket here, we've got the AMN rule here, which is AMN. We multiply. Okay, so this is going to be x10 and 2 times 2, y4, like that. And then you can just write this down. 4x minus 2, y2. Not finished yet. Now you see you've got x here and you've got y here. So we need to put them together. And the 6 on 4 will become 3 on 2, won't it? So I'll simplify this here. 3 on 2. Now we subtract our powers here. And they're always written on the top. So if you bring your minus 2 up, it would become plus 2. So it would be x 10 minus negative 2. Because remember, we're subtracting because we're dividing here. And that would be y 4 minus 2. So that's one thing you may mess up at the start. So do it like that. So then we'll have 3 on 2. Well, that's finished. 10 minus negative 2 is 12. And 4 minus 2 is 2, so y2. And these are both positive, so that's your final answer. And you can put the 2 underneath in the middle a bit. Or you can write 3 on 2 out the front, x12, y2. That's also okay. That's the same as this one. If it's written like this, 2 is actually in the denominator down here. So that's your answer there. Okay, I'm going to give you 10 minutes. You work for a while and see how you go on this first section. We won't skip any yet because we're just starting out. 10:44. So let's go to 11 o'clock. Okay, that's 16 minutes. I'm going to let you work for yourself for a while and try and do these. But when you have a division here, I recommend to make this look like a fraction. So when you have a division sign, do it this way. Like that. Just write it as a fraction because we have a division sign. Okay, you do that for a while and I'll be quiet for a while and I'll come back at 11 o'clock and then we'll do some answers. You can see the error I made with this question here. The 6, I forgot to square the 6, didn't I? You see that there? It's 36. That's 36 here. And that's still 4. So 4 into 36 is 9. So this actually is 9, not 3 on 2. Yeah, if you see something like that, let me know. So 6 squared, 36. And 4. And 4 into 36 is 9. X12, Y2 for that one there. So I'll do a few solutions here. You keep working. So that's 9, X12, Y2, that one. Let's write that here. That would be 9 here. Okay. So in this question, you could have cancelled the 7 and 21. I hope you did that, which will give you 1 on 3. So you're going to have y 2/3. Now you're dividing the numbers, so we have to subtract the powers. Minus negative 1/3. And we have 3 in the denominator here. So you get y 2/3 minus negative is plus 1/3. So 2/3 plus 1/3 on 3. So you should get y 2/3 plus 1/3 is 1. So you should get y on 3 for your answer there, okay? So that's your answer for that one. And for C, there's a couple of ways to do it. I did inside the bracket first. So let's do the way I did on my answer key. So you got 2, 4. 4, 0. And then we've got 4 to minus a half, which is 2 squared minus a half cubed. 4 power 0 is 1. So basically that's gone. You don't need that middle bit there. So then you've got 2, 4 times 2. 2 times minus half is minus 1 cubed. So that's going to be 2, 4 plus negative 1 cubed. 2, 4 minus 1 is 3 cube, and you should get 2 power 9 then for that one there. Okay, hopefully you're following because you're going to see this in your worksheet, but not yet. I'll give you composite before this one. But you might start getting 2 sheets a week. So you're going to be quite busy with the homework. We need to get through it fairly quickly. So in this question, you see you've got powers. Okay, so let's make that a bit bigger. Easier to read. So here, what I would do, I would change my numbers to powers. So 8 is 2 cubed. That's the one that makes sense because you got a half there, and you can't square root 8 anyway. So 64, I made that 64 2 power 6 2/3. Now I've got base 2, and I'm making everything base 2 here. And 16 is 2 power 4. So you see what I did there? I made my 8 2 cubed. I made my 64 2 6. And 16 is 2 4 here. So then I can multiply these out. So 2, 3 on 2 times 2, 6, 3 into 6, 2, 2 2s are 4, 2 power 4, and 2 power 4 for that one there. So when you add these together, we'll have 2, 3 power 2 plus 4 plus 4, which is plus 8. Now I could make this a single fraction, 3 on 2 plus 16 on 2, because 16 on 2 is 8, isn't it? I did that, so now I have a common denominator. 2, 16 plus 3 is 19 on 2. So you can do that in your calculator anyway, but you should write your answer out as a fraction. So don't write a decimal here. Keep it in that form there. So that's your answer there. 2 power 19 on 2 for that one. So copy that down if you're copying. Not sure when we're going back to school. If we go back, I think at the earliest it will be semester 2. So semester 1 school will be all online school. Okay, so if you look at this question, F, hopefully you're up to there. If you're not, you can take a look. So for F, we've got 5 2/3, 25, and 125. So it's looking to me that we would make these power with a base 5. So we want to use base 5 for these questions. So 5 to 2/3 is okay. So we leave that alone. Now 25 is 5 squared. So we put square here, and then that's 1/3. Now 125 is 5 cubed. And this is 4 on 3. So now we see what we can simplify. So 5 2/3, and this will be 2/3 as well. And this would be 5 power 4, because that 3, and that will cancel when we multiply. So you're going to have 2/3 plus 2/3, which is 4 on 3. Divided by 5 power 4. Okay, so that's going to be 5, 4 on 3, divided by 5 power 4. And here we will, I didn't have to write that, but now we would subtract the powers. 5, 4 on 3 minus 4. So if you are without a calculator, you would make a common power. 5, 4 on 3 minus 12 on 3, because 12 on 3 is 4. And so that would be 5, 4 minus 12 minus 8 on 3. Okay, so nearly done. And that would be, if we want a positive power, 5 power 8 on 3, like that. So either way is okay, but if I want positive power, you need to move the number down there. So we've got about 10 more minutes. So hopefully you're moving along. So that one's there. If you're copying that, copy that. Now go down. Now G, I have to see what's in your book. Let's go down. I've deleted some from my original sheet here. I got an answer key, but it's got more questions, so I've got to check which is which. Okay, this is a fun one. This is actually from a Thai book. So think about how you're going to do this one. I'll wait a few minutes, see if you can work it out. The 18 can be changed to 2 times 9. 8, make that base 2. So if I'm starting this, I'm thinking I want to change these bases. So the 8, I would change that to 2 cubed. So that's your first step. Try to get these to the same base, and you can actually get to the same base for most of these. So 2 cubed is 8, that's 2/3. For the 18, what I could do is I could change that to 2 times 9, which is 3 times 3, couldn't I? And that's all power half. So do that first. I did that for a reason, so you'll see in a minute. Now 144, what did I change that to? 12. So this one, you're going to have to think about what you're going to do here. So you've got 144 to a quarter power. That's this one here. And 144, try to change that to smaller numbers. So 144 would be 12 times 12, for example, and then you can change your 12 times 12 to smaller powers. What have I done here? So what I would do, change that to 12 squared first, which is 144, that's a quarter. So that would be 12 to the half. So this is the same as square root 12, this number here. And 12 to the half would be 2 times 3. Yeah, I won't give you many like this in the homework, but you should show the working like this. 2 2s are 4, 3 4s are 12 to the half. And root 6 is 6 to the half, isn't it? Root 6 is half power. So that would be 2 times 3 to the half. Like that. Okay, so I made everything base 2 or base 3. So in this first bit, we only have 5 minutes, so we'll try and finish this one. So for the blue bit here, we can multiply 3 times 2 and 3 is 2 squared. Now this, I will use this rule, ABM, which is AM times BM. I'll use that rule here. So 2 to the half times 3 to the half, everything to the power, times 3 to the half. And this will all simplify out. This will be 2 to the half times 2 to the half times 3 to the half times 2 to the half from this one here and 3 to the half. So basically I multiplied out this, became this here. And the yellow one became this here. And I did the same with the top. So this is blue. Oh, the first one is blue, sorry. So the first one is blue here. And let's do purple for that one. It's a bit dark, but that's this one here. Can you see that? So they're all broken down to smaller pieces. I don't like that purple, so I'll get rid of that. Can't read it. Okay, so then we look at what can we cancel. Is there anything that can cancel out? So 2 to the half, 2 to the half. What about 3? 3 to the half, 3 to the half. 3 to the half, 3 to the half. So you're going to be left with 2 squared on 2 to the half times 2 to the half. So you've got 2 squared on half plus a half is 1. You're going to get 4 on 2, which is 2. So that's your answer there. All that work just to get 2, right? So if you have a photo math app, you can check you're working with these here, that you got the correct answer. So if you want to write that down, you can, but you're going to get a few like this in the homework that take a while to do. Okay. What do we got here? Oh, I missed that one. And that one. Sorry, I skipped down. So I can give you the answer anyway. We only got 2 minutes. So go back to E. I completely didn't know I was on the other side because I was zoomed in too much. 64, I would make that 2 power 6. 1 6. 3 squared is okay. That's already simplified. And 64, 2 power 6 here. And that's a half. 6 times a 6 is 1. So 2 power 1 times 3 squared times 2 into 6 is 3. 2, 3. Like that. And then what do we got? 2 cubed minus 2 power 4. 2 power 4 times 3 power 2. Yeah, they're all different powers, so you could just stop at this point here. I think my answer key gives a different way. What you could actually do at this step, if you want to get closer to the answer key, this would be 2 squared times 3 squared. That's going to give you 12 squared. That's another way. That's probably better because it's got one base for that one there. So you could write it like that, but then I simplified this bit here. And this is 4 times 3, which is 12 power 2. So you could get to that answer there. All right. It's 11:10, so we'll stop there. And then let's see how we're going. I might leave a few for you to do yourself. There's a few here. This is kind of long, but that's a bit of a challenge. So if you want to try that one, try that one. There's a couple more here. We may do them on the next period. I think we'll spend one more class on this, okay? So we're down to about here then, and we'll finish these next week.